Okay, fifth graders, today is Tuesday, October 22nd, and we are continuing on with Module 2, Lesson 11. We've been working a lot with area models and unit form to help us multiply decimals and whole numbers. And today I'm going to show you another way to multiply. And the way that we're going to be doing today is by changing the problem. We can temporarily make a change to the problem to make it easier to solve, but then at the end we're going to undo the change. Okay, does that make sense? Because if I change something temporarily and I want it to be a temporary change, I have to undo that change to change it back. Okay, so I'm going to show you what I mean by that. And also we're going to use estimation to continue to see if our answer is reasonable. But first let's talk about the problem of the We've learned, and this problem of the day is a great reminder, that we've learned lots of different ways to multiply. We've learned how to use an area model. Right? That would be when we did, we know we need to find the area, so that would be taking 43 and turning it into 40 and 3, 13.5 into 10, 3, and 5/10. And then we could find all the partial products and add them up. Yes? We've also learned how to use unit form. And unit form is when we say, instead of 13.5, we can call it 135 tenths. So we could do 135 tenths times 43. And this is like what we did in yesterday's lesson. Yes? Okay, go ahead and choose what between these two methods, which way you would like. And either complete your work or use the other one to check your work. So by using the unit form method, I got 580.5. That's the answer to my first question, which was what is the area? So if I know that it's 43 feet by 13.5 feet, my area is going to be in what kind of units?
Feet squared.
Square feet. Good. Okay, so it's 580.5 square feet. Now, can I go to the store and buy 580.5 tiles? No, because I can't go to the store and say, please break this tile in half. I only want to buy half of it. So how many tiles then will he need? 581 tiles. Good. If I only went to the store and I only bought 580 tiles, would I have enough? No, I'd be half, 1 square foot too little. So I need to buy extra and cut it at home by myself. Make sense? And, you know, as I just said, we have 3 different ways today. We're going to do area model, unit form, and change/undo. But for all of those ways, we can always use estimation to help us, right? Because estimation tells us whether our answer is in the right zone. So let's first start by copying this problem down. 7.38 times 41. And then we're going to use some estimation. 7.38 is pretty close to 7. 41 is pretty close to
40.
Okay, and using math facts, I know that my answer then should be pretty close to 7 times 40, which is 180. Okay, that's not our final answer, but we're going to tuck that little piece of information aside so that at the end we can check to make sure. If our answer is not close to 280, we did something wrong. Okay? 7.38 times 41. That's hard to do because there's decimals, right? We can't really do this. We can't actually do the standard algorithm when there is decimals. But I can temporarily change this problem. Next to where you wrote the problem, I want you to literally write the word change. I can change it from 7.38 to 738. How could I change that factor? What do I have to do to 7.38 to change it to 738? Ikaksh? Multiply by 100. So I literally want you to write the word change and then write this math sentence. 7.38 times 100 equals 738. I'm actually going to change the problem now. Instead of 7.38, I'm going to change it by multiplying it by 100, and I have a new problem. My new problem is 738 times 41. Do we know how to do that? Yeah, that's just normal standard algorithm math. We can totally do this multiplication. Let's do it. 1 times 8 is 8. 1 times 3 is 1 times 7 is great. Now we're working in the tens. Put a placeholder 0. 4 times 8 is
32.
Good. 4 times 3 is plus 3? 15, good, yeah. Don't forget to say 15. Now we're only writing 5, but we have to regroup the 1. 4 times 7 is 28 plus 1? Good, I have my 2 partial products as expected. Let's go ahead and add. 8 plus 0 is 8. 3 plus 2 is 5. 7 plus 5 is 12. Regroup the 1. 1 plus 9 is 10. Write the 0, regroup. 3 is the last one. So our product is 30,258. But here's the thing. We changed the problem before we started. What did we do? What was our change? Times 100. So to undo, if I multiply something by 100, how do I undo that? What's the inverse operation of that? Gara? Divide by 100. Good. So I have to take my final answer, which was 30,258, and divide it by 100, which would be 302.58, right? Because remember, when I divide by 100, I have to shift to the right 2 times.
Yeah.
Okay, which looks like the decimal's moving 2 times, right? Okay, so my final answer then is 302.58. Let's check that against my estimation. Is 302 pretty close to 280? Yeah, so I feel pretty good about that. So here you can see it's called the change and undo method because I first change the problem to get rid of the decimal point, really, and then I undo the change to make it back to my normal problem.